Today I am going to discuss statistics. We have already discussed most of the Python's language coding basic. So now I am going to discuss because we will start machine learning and artificial intelligence of NL programming. So let's before we can start the basic statistics to use in Python. So first, basic statistics means if I start from mean, so everybody knows about a mean, median, mode. If you don't know, you must to learn mean, median, mode. So if you need to more detail, so you read the some my blog like this one, and I have already given so many things like here, and okay, so you try to so you can go my blog and you can learn number of things. So you can reload. Yeah, you try the alternative way. So what is the mean? Mean means sum of observations divided by data observations, means total number of the observations is called a mean. So mean, why do I use a mean? Mean as a look like a parameter. Sometimes I need to like something predict above the mean and below the mean. So there are many ways we can predict a mean, and we can see a detail. Similarly, the median is the middle value. So there is a formula to the median. You can different type of the data. Is it like a frequency data? It is like a continuous data. Yeah, it is like a individual data. So it has a different way we can get a median. Otherwise, you can understand the median is the middle value. Mode means the most number of frequency. This is the mode. Now after this, we can study standard deviations. Standard deviations we can get like a volatility, and then variance, the square root of st is called variance. Then we can study the correlations. So if you want to study about the correlations, so let's see, you write here the correlations. So if you write correlation, right? So we can say sorry, I have gotten something mistake here. Correlations. So I think it is possible to can get something here. Okay. So let's see. So correlations means like a positive correlations, negative correlations, and so you can see the so many times here. So positive correlations means most of the time you can see the correlations means -1 to +1. So if value is 0, so you don't have any correlations. If you go the -1, so it has a negative correlations, and if you write here the +1, this will be a positive correlations. Now the percentile and quartile. So quartile means like a just 25 means 1 by 4th, 50% quartile, and 75% quartile, similarly 100%. So percentile is also you can do same way. So quartile means just like a divided by 10, and percentile it will be divided by 100 this way. So if you want to get a knowledge about a theoretical, so you write here the percentile, quartile, deciles, and you can search the Google and you can get each and everything solid. Otherwise you can see the in my blog also. So look here. So percentile, yeah, look here, percentile. So you need to understand, look here, percentile means each of the 100 equal groups. Same quartile if you write here. Quartiles. So quartile means each of the 4 equal groups, right? So these are way to understand. So let's see. First I am going to create a data. So I have written here the data, and first it has been represented as a AC. This one like a dictionary type of the data. So AC, and another is the teach, or third is the text. So I have taken a 3 column. One is the AC, represent a variable, teach another variable, and text. So we can, I am making my own data. Now import a panda, because extraction of the data, framework for data, so we need to a pandas. So df will equal to panda data frame, and we can create the as a panda. So in the this data has been look like in pandas this way. This is like a structured way. So panda is a very important and powerful tools. Just it is similar to the SQL. And now I am going to import the statistics. So let's here import statistics, and I want to find here, because this data has been written as a df, and AC will equal to AC, means I am taking the only this column, AC column. So z numerators, so AC minus statics dot mean. So need to create here the mean, and now the z denominators is statics and standard deviations, and now the z as a numerator divided by the denominator, so we can get a z. So we can get a z numerator and z denominator, and so we can easily get a AC will subtracted from statics dot mean, and now the statics dot standard deviations, so we can get a standard deviations. So now I want to get a standard deviations, so you can print here. So now if I like to print here this one, okay, print, and this will be, so look, yeah, so we can get the standard deviations, and another is the z. So we can print here the z, so we can also write here print z, print, and now we can get, so we need to print z at this one. Okay, so this standard deviations is the all of this value like AC. So is it clear? So what is the standard value of this column? Means AC, yeah, till last is this 9.64, and now we can get the each z means z numerator divided by the z denominator, so we can get it. Similarly, I am going to import, if I like to describe here this one, so df dot, okay, if I want to create this one, so if I write here df dot info, so you can get informations about a data, and if you want to get a, yeah, look here, so it has a given all informations about this data. Another, if you want to write here, so df dot describe, so we can get here another informations, so describe, yeah, otherwise you can write here the info, yeah, you can get the same, and describe means yeah, I have gotten here, look here, df test means I have gotten the count, there are 24 rows has been given, and mean 79 and 2.5 here, teach mean and text mean has been given 1.5. Standard deviation, just look here, in before we have gotten the 9.6, so this one is the, so now teach standard deviation is given here. What is the minimum value is the 65, and teach is the 1.0, and text is this. Another, the 25% of here quartile has been given, so 25% is the 72, and teach 1.7 and 1. 50% means just like a median, 76, here is 2.5, here is 1.5. 75% is the 86, and 3.2 and 2.0. Maximum is the 95, and here is 4 and 2. So it has been described by a whole statistics. So now import a statistics, so it has been, I have already discussed here. Now I am going to import from SCIPY import stats. So stats and z score, so I need to get a AC z score, so we can write this functions stat dot z score AC and axis 0 and DOF I have taken 1, so DOF has been, so stat z score has been created. And why do I use the z score? So look here, what is the z score? So z score so look here, z score is a numerical measurement that describe a value relationship to the mean of group of values. So z score is measured in a term of standard deviations. So we have gotten standard deviations from the mean. So if the z score is 0, it indicates that the data points score is identical to the mean score. Okay, so let's see how to calculate a z score. So z square means you can write here x minus mean, x as a data, okay, AC, and mean I have already gotten, so and it will be divided by the standard deviation. So where x is the raw score and mean is a population mean, and standard deviations or is a population of the standard deviations. The formula is show the z square is just simply the raw score minus the population mean divided by the population standard deviations. So look here in this data AC, and I am getting a z score. So AC z square means AC minus mean. So mean, I think we have already gotten a mean. Look here, just describe here where is mean. Yeah, 79.04 will subtracted off from each elements, okay, from each column, each row, like this way. So and then we can get here all the z square from, look here. So z score, look here, is the all are, this one is the negative, this one is the negative, this one is the negative. So most of the time is the negative. So just we have already discussed, means z score is a numerical measurement that describe a value relationships to the mean of a group of value. So z score is measured in a term of standard deviations from the mean. If z score is 0, it indicates that data point score is identical to the mean score. So after that, so similarly, just we need to plot of z score. So look here, we need to one more library, import a matplotlib pyplot. So this has been plotted. Now ac.df ac and z will equal to stat z score ac, just we have already discussed, and we need to a histogram. So plt dot histogram and ac. So first I am plotting the data, already the previous it has been given. So AC means original data, and now I am going to plot like a z score right here. So z scores, look here. So are you getting some differences look like in this data? Here it has been the x-axis represent the 0, minus 1.5, 1.5, okay, look like this, and here you can numeric the maximum value is the 95 at the AC. So similarly the import SCFI as a SP and SP as a stats skewness. So I need to get a skewness. So look here, import SC as SP. So what is the skewness? So let's see, skewness means what is skewness? Skewness means it shows the data look like this way. So skewness is measure of the asymmetry of a distribution. So a distribution is asymmetrical when its left and right side, so this is the normal distributions, and left and right side are not mirror image. So a distributions can have a right, means agar if the it is a right means it has a positive, and left then negative. Left means negative and right means positive, and zero skewness also. So look here, how do I write here skewness? The this one like a momentum. So mu 3, momentum 3, like this one. So skewness it can represent this one, and it will start from I to n, xi minus x mean whole divide means to the power 3, n minus 1, capital N minus 1. So number of variables in distributions, and it will be standard deviation skew, right? So this one has been, so look here, what is the skewness is has been given here 0.38, approx 40% skewness. Similarly, I need to get a kurtosis. Kurtosis means it represents like kurtosis kurtosis look here. Look like a kurtosis is a measure of tailoredness of distributions. Yani tailoredness is how often outliers occurs. So excess kurtosis is the tailoredness of distributions relative to normal distributions. Distributions with a medium kurtosis, medium tails, are mesocuratics. So distributions with the low kurtosis, thin tail, and are platykuriotic, right? So kurtosis means momentum 4 by divided by the standard deviations to the power this one. So this is a way. Here is the means you can see their height like this way, so it can represent like a kurtosis. So look here, the kurtosis we had, it has been gotten here the minus 1.21. Similarly, we can take here one is the another data frame just, and it can represent this one df. And now again we can apply here from science pi the simple way to the test here has been given. And now I want to take the two means trial 1 and trial 2. There are pair of the data, because we need to if we want to get a correlation and something, we need two data. So pair, and I have a mentions just two data has been written. This is the way, trial 1 and trial 2. And now I want to go like a test t-test in these two data. So statistics, the first data has been given that this one is the t-test, and the p-value just similar to the probability here, it has been given here. Now import the C word SNS, because we need to visualize, and PLT means plot here. So distributions plot, we can say the trial 1 we have already taken here. So look here, what type of the trial 1 look like this is look like a normal, and one value is also. So your value between like 8 point something and till 12 point something between. Okay, so this is the density variable. And similarly we can distributions plot. So look here, the trial 2, it has been distribution plot look like this. And now chi-square test. So chi-square test, look here, like here, chi-square test. So what is the chi-square? Chi-square means, what is the chi-square statistics means, like you can represent the x square and the test that measure the how the model compared to the actual observed data, and the data is used calculating the chi-square static must be a random raw, mutually exclusive draw from independent variables and draw from a large enough sample. So look like here. So import this test and like a matrix this way, and from the SCPy import the chi-square contingency, and then we can get an array. Now the chi-square we have already gotten this here, look like this. So these are the observations from this value. Now if you want to create look here, data AC, teach and DF, and these are already we have already create So here we have taken the only the two variables, one is the AC, another is the teach, and now I want to plot AC dot histogram by the DF teach. So look like this. So it will plot, we can plot look like this way. So this one is as a AC, here is also AC, is a different way. Now I want to the like a sum of this data, we can get the sum. If I want to get a mean of this data, so we can get a mean. If you want to get the all, means all columns, so you can write here the AC mean standard deviations and teach standard deviations. Few seconds you can get these things. So medians, so look here the median here, and I have already described, you can use here the describe, and these are the import the SC pi as SP, and now I can use the Sepido sharp ratio type here, and DF you can write here stats in the this one statistics, and p value has been given here, and another is the ANOVA. So look here, ANOVA in the Python we can use, and it can represent like this way. So similarly, I hope how do I use Python some stats models and statistics. So these are the way, and next time we will learn. Look here, this data means sum of the squares, DF, I have F value, and probability is a greater than. So you must understand basic, and then how to use in as a programming and machine learning, and we also discuss some statistics rules in artificial intelligence. So these are the basics. I think you can understand, and you try your best. Thank you.